this video. All right, this week we're learning about stoichiometry. I'm gonna go over the notes first. So as I said before, you can take notes directly on your Google Doc, or you might want to take notes in a notebook or on a separate sheet of paper because there's a lot of calculations going on. So you might want to write it out on paper. All right, so to start this topic, I gave you guys an example of making a sandwich. So the recipe for making a sandwich, the one that I have here, is that with 2 slices of bread and 3 pieces of lunch meat and 1 slice of cheese, we can make 1 sandwich. So according to the recipe above, what is the ratio of slices of bread to pieces of lunch meat needed to make 1 sandwich? So I'm asking you to do a ratio between bread and lunch meat, and we see it right on the recipe. With the recipe, we need 2 slices of bread for 3 pieces of lunch meat. So you can either write it like this, or in math, we tend to write ratios as fractions, like 2/3. So given that ratio, if you have 9 pieces of lunch meat, how many slices of bread do you need in order to make the perfect number of sandwiches? So I know you guys can do this math in your head, but I want you guys to get in the habit of doing it out using a ratio. So you're given 9 pieces of lunch meat and you want to figure out how many slices of bread you need for to make a sandwich, to make however many sandwiches. So what you have to do is you have to multiply by the ratio. 2 slices of bread over 3 pieces of lunch meat. And we get 6 slices of bread. So the math here is 9 times 2 over 3. So we're doing 9 times 2 divided by 3, right? And we get 6. So this is the type of math that we're going to do for this topic. So moving on. So for making a sandwich, we use the ratio of ingredients in order to figure out how many of each ingredient we need or how many sandwiches we can make. Similarly, we can use ratios of reactants and products in a chemical equation to determine how much reactant is needed or how much product is produced. This quantitative relationship between reactants and products in a chemical reaction is called stoichiometry. So I just defined what stoichiometry is, right? Stoichiometry is the quantitative relationship. Quantitative just means numerical, right? It deals with numbers. Numerical relationship between reactants and products. So think of it this way. So if we have this many reactants, how much product can be produced, right? So it's a quantitative, a numerical relationship between reactants and products. We're going to look at some examples together. First, let's look at the reaction for synthesis of ammonia. All right, so we have to balance this equation first, so I'm going to do that right here. So these coefficients are now, so we're going to call these numbers moles now, okay? So what this means is 1 mole of N2 reacts with 3 moles of H2 to produce 2 moles of NH3, okay? So what is the ratio between nitrogen and hydrogen? N2 and H2 is 1 to 3, right? 1 to 3. What is the ratio between H2 and NH3 is 3 to 2, right? There's a 3 in front of H2 and 2 in front of NH3. So these ratios are called mole ratios because these numbers, we're going to call them moles now. So we're going to use mole ratios to figure out to do calculations for chemical reactions for this topic. All right, so let's look at this question. If 6 moles of H2 react in this reaction, so if we have 6 moles of H2, how many moles of NH3, ammonia, how many moles of NH3 is produced? So we're given 6 moles of H2 and we're trying to figure out how many moles of NH3 is produced. And we're given this reaction equation. So we can call this our recipe, just like our sandwich example. So the given moles is, we have 6 moles of H2, so that's given to us. We know that we're starting with 6 moles of H2. And we're trying to figure out how many moles of NH3 is produced. So just what I have here, this is going to be the mole ratio. You're gonna put the unknown, so we don't know what the moles of NH3 is, right? So we're gonna put 2 NH3 over 3 H2 because that's what the recipe calls for, all right? So that means we're gonna do our math problem here. 6 times 2 divided by 3, and the H is canceled out. H2s cancel out. So we have 6 times 2 divided by 3, and you get 4 moles of NH3. And this is what the question is looking for. How many moles of NH3 is produced? All right, so we're gonna do one more question on this and then move on. So we have 8 moles of NH3 is produced. How many moles of N2 were reacted? So we're given 8 moles, so that's what we start with. And we're solving for moles of N2. So that's the unknown. So that's 1 N2 over the given, which is 2 NH3. Right, so we're just using the recipe that's given, just like our sandwich example. So 8 times 1 divided by 2 is 4 moles of N2. All right, so we got our answers right here. All right, so for these type of questions, all you're doing is you're multiplying the given by the mole ratio of the unknown over the given. So the next question asks you to do how many grams of N2 were used in this reaction. So you're given, well, you're not given anything here, but we know that from the previous question, we needed 4 moles of N2. So that's the number that you're going to use because we're dealing with N2 right now. But whenever you see the word grams, we have to think molar mass, right? We need to solve for the molar mass of N2, which is 28.02 grams per mole, okay? So I'm gonna use the moles that we figured out in the previous question. So that's the given from our previous question. And we're solving for grams. So this is a mole to mass question, which is we need to multiply, okay? So I'm gonna put the molar mass on top, moles cancel out, and this is a multiplication problem, and I get 112.08 grams of N2. All right, so how many grams were used in this reaction? So we have grams as our final answer. All right, I know you guys might have questions, save them for the end, all right? I'm gonna go over the next set of questions. All right, so let's do a problem that combines the skills we learned in the past couple weeks. So first we have to balance the equation, Second, we're going to do mole ratio, and then we're going to use molar mass to figure out the mass of the product. So balance this equation. So I'm going to do that really quickly here. I get 2, 1, 2, 1. All right, we have 2 NaOH plus 1 CaCl2 produces 2 NaCl and 1 calcium hydroxide, CaOH2. Number 1, it says 4 moles of calcium chloride react in this reaction. How many moles of sodium chloride is produced? So we're always going to start with the given, 4 moles of CaCl2. And we're looking for moles of NaCl, right? So we have to look at the recipe, our chemical equation. For every 2 moles of NaCl, 1 mole of calcium chloride is reacted, right? I'm getting it from here, guys, mole ratio. So to do the math problem, we do 4 times 2, and that is 8 moles of NaCl is produced, okay? Number 2, how many grams, so as soon as I see grams, I'm thinking molar mass. How many grams of NaCl is produced in this reaction? Well, we already got the moles of NaCl, right? So I'm gonna bring that down. So that's how many moles. So we want grams. So we're going to multiply by the molar mass of NaCl. So NaCl is 58.44 grams per mole. So if I do the math out, 8 times 58.44 grams, I get 467.52 grams of NaCl. All right, so that's it for notes. You're going to use these notes to do the practice problems. All right, so I'm going to, why isn't this working?